In this video, I want to show you guys how to divide polynomial functions using synthetic division. So the first thing we want to do is we want to take the coefficients of our top function and write them in here. So our first coefficient of x cubed is 1, and then -2, -5, and the constant of 6. And then to figure out what we divide these numbers by, we take our bottom term down here and set it equal to 0. And then we just solve for x. So x is equal to 3. Another simple way we could do it, instead of just doing that every time, is you just switch the sign. So you take this right here, and instead of a -3, it's just a +3, and that's what you would put here. Okay, so the way we divide this is we start out by just bringing down the very first number, and we just write it down here. And then what we do is we multiply 3 by 1, and then we write whatever we get here, so in this case 3, and then we add. So -2 plus 3 is +1, and then we multiply again. 3 times 1 is 3, and then we just repeat the process until we're finished. So -5 plus 3 is -2, and then 3 times -2 is -6, and 6 plus -6 is 0. And this last number right here is actually equal to our remainder. And if we get a remainder of 0, that means x minus 3 is a factor of x cubed minus 2x squared minus 5x plus 6. Okay, so the way that we continue with this is these numbers right here are going to be our new coefficients. But instead of starting with x cubed, so the highest power of this function up here is x cubed, what we want to do is we want to subtract 1 from each one of our exponents. So instead of x cubed being the highest power of this polynomial function, the highest power of our next our divided polynomial function will be x squared. So this is going to be our x squared term, or x squared coefficient is going to be our x, and then this is just going to be our constant with the remainder of 0. Okay, so this is going to be 1 x squared plus 1 x minus 2, and that is going to be the answer to this problem. So for our next problem, we're going to start out the same way. We are going to take our coefficients and then bring them down into here. So for x cubed, we're going to have 1. We're going to have -2 for x squared, 3 for x, and then our constant of -4. Then we're just going to switch the signs of -2 to find what we're dividing it by. And then we are going to bring down our 1. And then we're going to multiply 2 by 1 and get 2. Then when we add these up, we're going to get 0. So 2 times 0 is 0. And then we are going to add, and we're going to get 3. Then we'll multiply. 2 times 3 is 6. -4 plus 6 is 2. And then this is our remainder. Okay. And then what we do just like we did last time. Our highest term of our original top polynomial was x cubed, so we're going to subtract 1 from that, and this is going to be our x squared term, this is going to be our x term, and this is going to be our constant. Okay, so we're going to have 1 x squared plus 0x to the first plus 3, and then for our remainder, what we do is we take our remainder, so plus, we take our remainder and then we divide it by what we were originally dividing our polynomial up here by. So this will be 2 divided by x minus 2, and then if we simplified this out a little bit just to clean it up and make it look a little better, we can just write x squared and then just have it as an implicit coefficient of 1. 0x is just 0, so we don't have to write it. So x squared plus 3 plus, and then our remainder of 2 divided by x minus 2. And that is the answer to this problem. So for our final problem, I want you guys to try this one out on your own. Okay, so what we're going to do, just like the other times, is we're going to take our coefficients and we're going to bring them down into here. But the difference for this is, as you can see, there isn't an x squared term. You need to write the coefficients of descending powers. So we're going to need a coefficient for an x cubed. We're going to need a coefficient for an x squared, for an x, and that's what we're going to need. But it's missing an x squared. So what we're going to do is x squared is actually a 0 because 0 times x squared is 0. So anytime it skips a power from like 4 to 2, you're going to have a cubed. So if your leading coefficient is the highest degree of 5, you need it to have the coefficients of 5, 4, 3, 2, 1. And if it's missing any of them, you're going to have to write a 0 as that coefficient. So we're going to bring down a 7 for x cubed. For x squared, we have a 0. For x, we have a 6. And then we have constant of -8. So for this, we're just going to switch the signs of -4, and we're going to divide all this by 4. We're going to bring down our 7. So 4 times 7 is 28. 28 plus 0 is 28. 4 times 28 is 118, or 112, sorry. And we're going to add 6 to 112 and get 118. And then 4 times 118 is 472. And then 472 minus 8 is 464. And this is going to be our remainder. Okay, so this is, as you can see up here, our highest power of our top polynomial is 3. So our highest power down here of our top polynomial is going to be 2. So this is going to be our x squared term. This is going to be our x term. This is going to be our constant. We'll just write a c, and then 464 is our remainder. So if we write this out, this will be 7x squared plus 28x plus our constant of 118 plus, you can't forget a remainder, of 464, and then we divide it by what we were dividing our original top polynomial by, x minus 4. And that is the answer to this problem.